అందరికీ నమస్కారములు. Today is the third and last day of our classes on Vedic mathematics by Dr. Goutham Mukherjee ji. We will start this session paying respects to our country by reciting Vande Mataram by Challa Chittibabu Garu and then continue with Prarthana. Challa Chittibabu Garu, please. Please unmute yourself.
Vande Mataram, Vande Mataram, Sujalam Sufalam, Malayaj Sitalam, Sasya Syamalam Mataram, Vande Mataram. Suprajosna pulakitayaminim pullakusumita drumadala shobhinim suhasinim sumadhura bhashinim sukhadam varadam mataram vande mataram. Vande Mataram.
Vande Mataram. ధన్యవాదములండి చల్లా చిట్టిబాబు గారు. Thank you so much. Going forward, let us request Venkat Narayana garu to chant Prarthana, please.
Meditation for a minute. Three times Omkar. Om Gananantva Ganapatigum Havamahe Kavim Kavinamupamashravastamam Jeshtarajam Brahmanam Brahmanaspata Anashunvannotibhisida Sadanam. Om Sri Mahaganadhipataye Namaha. Om Prano Devi Saraswati Vajebhirvajinivati Dhinama Vidyavatu. Om Sri Mahasaraswatyai Namaha. Gurureva Gatir Gurumeva Bhaje Gurunaiva Sahasmi Namo Gurave Na Guru Paramam Shishurasmi Guroho Matirasti Gurau Mam Pahi Guru. Jnananandamayan Devan Nirmalaspatikakritim Adharam Sarva Vidyanam Hayagrivam Upasmahe Shruti Smruti Purananam Alayam Karunalayam Namami Bhagavat Pada Shankaram Loka Shankaram Shankaram Shankaracharyam Keshavam Badarayanam Sutra Bhashya Kritau Vande Bhagavantau Punah Punah. ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमवद्व्याप्तदेहाय दक्षिणामूर्तये नमः। असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मामृतं ॐ शान्ति शान्ति शान्तिः। मातृदेवो भव पितृदेवो भव आचार्यदेवो भव अतिथिदेवो भव। ॐ सहना भवतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः। हरिः ॐ श्री गुरुभ्यो नमः। हरिः ॐ।
హరి ఓం శ్రీ గురుభ్యో నమ. ధన్యవాదములండి వెంకటనారాయణ గారు. Let us request Goutham ji to continue the webinar, please.
So yesterday we did some square root, taken square roots of up to where the square root actually of 4 digits, 3 digits, up to 3 digits. All were 3 digits. Now let us take a bigger one, and as it become bigger, it will be slightly more steps will be there. But the principle is, overall principle is the same. So instead of a plus b plus c c whole square, it is a plus b plus c plus d whole square. So accordingly, there will be cross terms. So this a, twice a you have kept aside, like 8 plus 8 into 2, 16. Twice a, with a it becomes a, b, a, c and a d. However, there will be also cross terms like BC, there will be BD, there will be CD. So those will come in appropriate places, and you have to act on them so that we gradually calculate all the digits of that. And we also confirm that there are no further decimal points are there. If decimal points are there, laying there, and let us keep it for practice of those who are highly interested or for the next level of the course. So again we do what we do. We get the task is square root of this one.
I think 21 is sir. 21 group digits of last two from right.
But group in this one, so that this 69, this particular part actually, this part fine.
Okay. Maybe 21 square root, last two digits from the right. So 21 square root we are finding and we are getting some reminder.
No, 21 square root will not come directly down. It will have to come from the left actually. So we do the doubling of the group, doubling of the digits from right, but we start with the leftmost ones. So 69. So 69, what to do about that? 69, we find that 8 is the closest one. 8 actually is the closure. 8 into 8 is 64. And so there will be 5 remaining. This 5, when mixed up with this 9, this particular 9, I mean this 9, this 5 and this 9, it became 59. And we twice A, this is my A, this 8 becomes my A. If it is A plus B plus C plus D, actually speaking, it is actually, if we take X as 10, X is equal to 10, actually it is AX cube plus BX square X plus D. But actually X is 10 and this pressing it to proper, pressing it into proper digit, proper place position of the digits, it takes care of this X factor. We can consider only A, B, C, and D. Now, my next goal will be to calculate the B. How to calculate B? Now, first this one is 5. Now, put down 8 and double this and double. So, twice A you have put in the, this is twice A. Now, next higher, the higher power of X, power of 10, will come with twice A. Next power of come will be, it will come with 2 AB, twice AB. Twice AB into proper X to the power, it was X cube, X to the 5 in fact. So how it came? So how it can come? Now I multiply 16, so double kept it, and the fourth step is 5 is 59, okay. And 59 is divided by 16, twice A. So when I'm dividing this by twice A, so it will produce B. Okay, that clear? So this 69 divided by 16, so it becomes 3. 3 and 16 into 4 becomes 64, more than 59. So it is 60, that this indicates the third digit. I mean B digit, second digit from the left. So this becomes my B, because 16 into 3 is the closest to 59, below 59. And what is the remaining? 11. That 11 with 0 became my 110, became the next step. And I have to subtract B. Now it is B square. B square I have to subtract from 110 and become 101. So, see, if you group it, there was the grouping. Algebra 1. Yeah. So, present case is of 4 digits. So, you see that a square x to the power 4. And now if I group it, group it. So, a square x to the power 6 means 10 to the power 6. And then twice AB. So, you know that this became 8 and this became our, in our case, become 16. This 16. So, I divided it 16 and by 16, the 59 divided by 16. So this gave me that 3 became my B, that in that example. And then there is B square plus 2AC. Now next step will be, C we do not know, but we know B square we know. So that we did. So this B square, I subtracted this 110 with B square, and become 101. Now what should you do? 101. Now 101 again, because there is this 2AC. Again, this 2A is coming, 2A is 16. So when we, after subtracting this B square, when we divide it by 2A, it will produce C. So that is happening, C. So 16, I put the third digit, 16. 101, you will divide by 16. So my A becomes 6. So this real becomes 6%. So this is my C. And put down the, and 16 into 6 is 96, and into 21, only 5 is remaining. This 5 mixed out with the next digit of the the square root candidate, the square, I mean, for which the square root will be there. So 56. This 56, I now want to do next step. What is the next step? Next step is that BC and AD. Here it is unknown still. BC and A, both are unknown. In fact, twice BC and twice A. So I first have to subtract twice BC. Twice BC. What to do? Yes. C2 BC. This is the twice BC. So 56, I am subtracting this 36 to get 20. This 20 is what? 20 is my twice AD. Twice AD is 20. So therefore, what you do? Twice AD is 20, and 20 when I divide by 6, it will give me D. This will give me D. So we are doing it opposite. We are totally analyzing this thing, this algebra, and step by step I am here evaluating this stuff. That is the idea. Keep on doing like that. So 56 by 20 and put down 4 digits. Now D is what? That if it is perfect square, you know, then the reality is already there, but we have to confirm that it is happening. So we let us go further, and remainder is 4. Remainder is 4 after processing that 16 into 1 plus 4 is 20. So this 4 along with this next digit of this thing, still 2 more digits are lying. Or are would be for the other parts. 43. But you have to confirm that yes, there is no there is perfect square. We still don't know. Now 43 and 43. What is 43? Now it comes here. Now here we know everything, all these things. But actually you have to again act with that. What you do? Then it becomes, put down this thing, and it becomes third, this is 43. And 43, subtract the square root of third digit, that is 6. So 43 and 6, it gives 7. So we subtracted this C square already. Now again we subtract 2 BD. Actually it will all produce 0. That is the idea. If had it not been a not been a perfect square, it would have been instead of putting 0, instead of producing 0 here, it will produce something else. So therefore it will become to fractional. It will become, have to go to decimal point. Now this 43, what do you do? Did 60, 20, 36 we subtract. So it gives 7. So 36 somewhere it came, actually I didn't write it because there was space to write. So 43 minus the square of this 36 gives 7. And 7, when we now everything will be small. So that when you divide it by 16, no, but you have to now divide it by twice b, 6. Twice b is 6, and this third digit is 7. Third digit, I didn't write all these things because they will spill over more than one slide. So now what you did? Now you found that this 7 is there, and 7 again we twice of this b. When 6 we subtract this 1, and it became 1. Remainder 0, it becomes quotient, and 1 became my remainder. 7 minus 6 is 1. So this now is 12. This 12. The 12 again, what is there? What is remaining? This is C square is already there. Now this one. Either of these things can be done. Better to do all this one. This side subtract first. These are all. No, this will come the last. This is there. These are to. So this 12 and 12 we actually twice C. See, twice C is there. Yes, twice C is 12. That 12, I'll take. See, now this is twice C. Okay, twice C. Twice C. So twice C became 12. 2 of this. Twice C. In fact, twice CD became 12. And that 12 actually subtract from 12, become 0. So 0. Now 1 is remaining. That 1 is actually against C square. You see? C square is 1. That 1 gets subtracted and finally produced. I think it is clear. How actually, if you analyze it turn by turn, actually response is slow, so it is forwarding sometimes. So you know the turn by turn how we did. You understood, no?
Yes.
So up to this fourth step, we still have some unknown value. So that after that it is only matching. If something remained, it will be producing more digits, so it will be fractions. Actually, in fact, the length of this thing expression will increase and so on. There will be more complication. Is it clear?
If anyone wants to say, please raise their hand. Otherwise, just
I'll go to
respond.
the other topics.
Yeah.
You can see yourself.
Yeah, Padmavati garu, you want to say something?
Yeah, please.
Padmavati garu.
ఒక్క నిమిషం ఇది ఇక్కడ 10160 divided by 16 gives quotient is equal to 6. Put it down as third digit of result అని చెప్పారు గురువు గారు. R is equal to 5 with R gives 56. ఈ లైన్ ఒక్కసారి ఎక్స్ప్లెయిన్ చేయమనండి గురువు గారు.
Yeah, this C 56.
Yes,
sir. 6. Yeah. This
101. This 101 divided by 16. Okay, give 6 into 16 is 96, and 5 will be remaining. So that 6 into 16. So when you divide this 101 by 16, the quotient becomes 6. So that produces my C. Okay.
Thank you.
Pantru garu.
Explanation per point 5, 101 divided by 16 gives quotients of 6. Put down as third digit result 5. Okay.
101 Yes,
From this, subtract 2 into 3 into 6. From where
Yeah.
1, 2, 3, 6 has come.
2 into 3 into 6. It is actually twice BC. Say twice A, I kept it here. Whenever required, I'll put it here. But I didn't didn't keep twice 3, twice B, twice C, etc. So these are actually this twice 2 into 3 into 6 is 36. Actually, it is coming from here.
Okay.
2 BC, 2 BC.
Is it required to know this formula, Gautam ji?
Huh?
Is it required to know the formula, or you can do it directly?
That will be mechanical. When this thing, what I see that if somebody, for me at least, it will be
Yeah.
difficult to remember what steps I am taking. So
But,
I can analyze it step by step with that, how we are gradually, gradually known things we are acting properly, and
right.
then gradually by division, step by step, the unknown things are coming and so on. But mechanically, if you just memorize that procedure, then you can do it also. No problem.
Okay, somebody is saying something?
As a procedure,
excuse
then
me,
you have
sir.
to memorize these whole steps properly.
Yeah, right.
Sir,
Okay,
excuse me, sir.
Ravindra garu?
Yes, sir. This is, in this case, 2 AC, the AC were doubled and make it to 36, we are subtracted from the 56. In the next stage, the next step is it 2 CD and multiply followed by 2 DE, 2 EF, like that it will come?
Yeah, of course, if there are more digits, but here up to CD is there, 2 CD. 2 CD came somewhere, and here itself. 2 CD, yes, this 2 CD was 12. This 12 we subtracted with this 12 to put in 0. Yeah.
So
Sir, I have a
subsequent,
small. Hello, everyone.
so subsequent steps is multiplication of the previous one. Say is it 2AB, 2AC, 2CD, 2DE, 2, like that it will
Yeah.
come, or any other thing.
Somehow we use always that. Twice BD also use 6 it came somewhere. This C, this, so it all came in the procedure.
But getting remembrance of this formula is too cumbersome when compared to.
It is better to follow these steps actually. This kind of thing. And I left it because I knew it is actually a perfect square. So just after this step, 2 into 3 to 6 and 36, it gets 36, 20, 56 minus 36, 20. And after 20 came 20 divided by 16, became quotient become 1. So that is that process ends here. Actually speaking, if I know that it is perfect square, my procedure, the process actually ends there. Only just rest is only verification.
So this 36 minus 20, okay, after that 43 minus again 36 it is coming, but in next case step it is not coming like that.
36 is coming because of it is actually C square. C square, the 43 is coming, all the digits are there. So all the digits, what they're doing. So you have to link that, no, with the others, other part of
36 means in this case 6 into 1 into 2 or 6 into 1 into square. Whole square of 6 into 1. CD
6 into 1, no, it is C square, 6 into 6.
6 into 6. Okay, here 36 has come in the third step.
Third step.
Okay, in the fourth step, again 43 minus 36 has come.
Oh, no. This 36 is different. This 36 comes from, this is twice BC. 3 into 6 into 2.
3 into 6 into 2.
2 into 3 into 6.
2 into 3 into 6.
This is the twice BC. Twice BC. And this 36 is actually C square.
Okay.
This is C square. And
this 36
came in appropriate places. See, this C square came here, twice BC came here. Actually, I should not have taken these two as a common. It should have been twice BC plus twice AD. Twice AD. But again, after subtracting this twice BC, what we did, I again this twice is 16, so this is x2. I won't modify it actually.
That x cubed, sir, this one.
Huh?
Is it x cubed? Huh?
X cube.
X cube. X cube is actually 10 cube, that is thousands place.
Here 2 into BC itself is coming to 2
twice BC is 36. I'll tell you.
2 BC 36.
36.
3 AD,
And,
3 AD again it is coming to in this formula 3 AD. A to 1D into 8 again 24 it is coming. 3 AD means in that 5. Please go to that principle.
20. This 20. D we do not know. This actually after this D will come. When we this 20 I divided by 20 I divided by twice A. Because see, I subtracted this 36, 56. There are earlier results are all 56. And 56, this divided by, subtracted 36. 36, this is 36. Now, this gave 20. Now, this 20 has a mixture of 80. Twice AD, sorry. Twice A is 16. So, when we, this twice is 16. When we divided this 20 by 16, it became 1. So, that 1 actually is the D. So therefore, it the rest of the things, what is remainder, mixing with the other places, the rest of the things. But here, it produced the D, because D is 1.
Goutham ji, namaskar.
Sir,
This, Hari Om.
here 2 BC, BC itself B is 3 and C is 6. 2 BC in that formula, that itself is coming to B into C 18 plus again AD. A is 8, D is 1. So 36, 3 BC 36 plus AD is 8. So 36 plus 8 is 44. 44 into 2, 88. Again into multiplication of x cubed, it is there in that formula.
So 80 part is already over, because AD
Sir, please go to that previous principle, sir.
Already added.
Sir, here in the 1 minute, sir, sorry, excuse me. This is first square step is a square x to the power of 6. Then plus 2abx, please for that formula, sir.
Formula?
Formula, earlier screen. Yes, sir. Here, this second, third, fourth one is plus 2bc plus AD x cubed is there. 2 BC, 2 bracket of BC. BC itself is 36.
BC is 2
36
BC
plus AD. A and D is 1, 8. 36 plus 8, 44.
16. Twice 80 is
36 plus 8. 30, A is 8 into 1 is 8. 36 plus 8 is 44. 44 is again to be multiplied with 2.
You are missing 2. The 2 is also there.
It was already 56. It was already 56. From where I subtracted this twice BC to produce this 20. 20 contains 2AD. Okay.
First, let me clarify, sir. This BC plus AD to be clubbed together, na, sir. BC plus AD first we had to club.
BC plus AD. This is C.
BC itself is coming to 36 plus AD 8. AD 36 plus 8 is 44. 44 again is to be multiplied with 2.
There is something more, not 44. It is 56 actually. Because there is some more terms. So
no, as per that formula, it is coming to only 44. 2 BC plus AD.
44.
2 BC plus AD. BC is 36. AD is 8.
What do you want to do with the 44?
44 it is coming now. 44 multiplied with 2 na is multiplication or what? Before that one. 2 within brackets BC plus AD is there. Then X cubed is there. X cube is there.
So you mean to say, should I evaluate all these
Gautam
things?
ji, just a minute. Gautam ji, just a minute.
Yeah.
Here, Ravindra Garu, just
Yeah.
try to see this term 2 into brackets BC plus AD X
Yes.
cube.
X
Here,
cube.
what the mistake that you are doing is
Yes, sir.
2 BC you are doing.
Oh, no.
Plus,
First,
just
okay.
a minute. Just
Right,
a
right.
minute.
Okay.
2 into BC you are doing.
Uh.
Plus AD, you are adding only AD. It is, you are supposed to add 2 AD. Hope I am right, Gautam ji.
Yeah.
See, first,
Plus
within the
2.
bracket we had summed up. Then it will be multiplied with the
Okay, you do either way.
it is
You do
coming
either way,
36
you will get
plus
the
8.
same.
36 plus 8 will come. BC is 36, AD is 8.
Okay.
Then it is to be multiplied with 2.
BC is how much?
36.
AD?
1. 8.
So Gautam ji, you here, you have to, maybe we'll take it up later. Things are getting confused.
There is
We
no
are taking a
confusion.
lot of time. Let us
Twice
go ahead.
BC. Twice BC is 36. Twice BC
Yeah,
is
yeah.
36. BC.
BC is like 18.
Please, we'll go ahead because
Yeah. Okay.
we are
So,
running out of time. We
so
are
this is
running out of
actually
time.
clearly, it can come clearly because we have already evaluated those things and step by step it came. So 44 doesn't come into picture because it is already split into 2 parts. I will come back to it later.
Right, sir.
Now I come to another topic called remainder theorem.
Okay, sir. Thank you, sir. Thank you.
Yes. Remainder theorem. Actually, I have some problem in my legs, so sometimes I have to change the positions.
Yeah.
The remainder theorem says that when a polynomial Px is divided by linear polynomial x minus a, then the remainder is equal to P of a. This is the remainder. It enables us to calculate remainder without actually dividing. And obviously, if the remainder is 0, it is actually divisible, or you can use a factor of that. So Pa is 0, it signifies that A is one of the root of the polynomial Px is equal to 0, and also x minus 1 becomes a factor of Px. Remainder theorem helps to factorize the polynomial of Px. So when you know that x minus a is a factor, so you divide that polynomial by x minus a, and it becomes a smaller one, and even again factorize it, and so on. Now, actually, it is sunnam sammo samuchyate. This is the basic formula for that, and meaning a common factor is the same, which is 0. So, common factor in this case is x minus a for the x minus a itself, and then the px, and gets transferred into 1. Sunnam, when this is 0, that the other also will be 0. So, sunnam sammo samuchyate. So, find the remainder when the polynomial Px 3x cube minus x to the power 4 plus x cube minus 4x square plus 2 is divided by qx, which is x minus 1. Solution. We will substitute the 0 of qx into the polynomial Px to find the remainder r. The 0 of qx is x is equal to 1. It is the 0 of. Because when x is equal to 1, qx becomes 0. So, by remainder theorem of R of P, R is will be P of 1. So, instead of X, I just keep on putting 1. So, what I do, instead of wherever there are X, this place is X, I put 1. So, 3 into 1 to the power 5 minus 1 to the power 4, 1, so on. And then I come evaluate it and comes to 1. The answer is 1. You will find in my slide these kind of things. Don't get confused. This powers, this one, because I have to cut and paste here, because these are not done by ordinary subscript and superscript. So that if this part is copied to WhatsApp on a text, this will also remain as power and subscript and so on. So these are actually indicate some higher values, not the ordinary numbers here. So you will find that you just ignore it. So the answer is 1. Now, find the remainder when 345 is divided by 345 is divided by 12. And this is application. I'm doing application not in algebra, but in basically our motto is in basic mathematics mostly. When in this level of courses, we are interested in arithmetic. Okay. Background, there will be background algebra, but they will be interested in arithmetic, because all of us are not very much interested in doing these expressions always. In polynomial, we do not handle polynomial much. We remain handling this one. Maybe that polynomial etc. will, maybe later we can introduce in second level, but at third level it can be introduced, because see there are, I open the book. How many of you purchased or ordered this particular book? So there are more chapters I didn't put in the slide. Various chapters are there. We'll totally with algebra, with x and so on. There will be common factor, factorization of polynomials. There will be merger. Various topics are there. Big things are there. Actually, not this all cannot be translated into. You see that all cannot be translated into arithmetic, number theory. Arithmetic is called also number theory. So you see that there is a lot of expressions and so on that we can keep for higher, courses. No, so therefore, after learning this remainder theorem, what we do, we apply to our arithmetic problems. So 345 is divided by 12. So 345 is expressed as 3x square for x is 10. 3x square plus 4x plus 5. And similarly, 12 is x plus 2. X is 10, x plus, so x plus 2 is 12. So therefore, this x plus 2 is equal to 0 produces x is equal to minus 2. And according to remainder theory, this minus 2 has to be put in place of x in 345. So 3 into this, wherever there is x, we put minus 2. So minus 2 square, 4 into minus 2 plus 5 becomes 12. Minus 2 square is 4. 4 into 3 is 12. And minus 4 into minus 2 is minus 8. And plus 5 is 9. Found that equal to 9. So it becomes the remainder. Find the remainder when 1345 is divided by 13. 1345 is x cube, 1 into this thing, x cube, and 3 into x is 3x square, 4x 5, and x equal to 10 obviously. And similarly, 13 can be expressed as x plus 3, and 0 becomes x at minus 3. So according to remainder theorem, putting minus 3 in place of x in this 1345 gives this one. All minus 3 are put, minus 3, minus 3. And so minus 3 cube is minus 27, and this 3 into minus 3 square is 27. The minus 3 square is positive 9. So this thing minus 12 should be the minus 3, minus 7. So minus 7 cannot be, negative remainder is not there. So there will be one more thing has to go, and therefore actually remainder is the original divisor. Algebraically added or subtracted, the 7 is subtracted, so get the actual remainder. 6 becomes the remainder. Find remainder when 27846 is divided by 8. the number 27846 is expressed as this one. 2 into x to the 4 and so on, x is 10. And 2 into 10 to the power 4, 20,000. That's 7,000, that's 800 and so on. So similarly, 8. Now, 8, we convert it into vincula. 8 becomes 10 minus 2. So x minus 2. So x 0 is x is equal to 2. So in place of x, we put 2. So it comes to in original expression. Wherever there is a x, we put 2, and this 2 with this one, we calculate, it becomes 134. Again, 134 cannot be a remainder when we are dividing by 8. So we have to repeat the process until and unless the second step, 134, it became, when you put 2. So 1x square plus 3x plus 4. So 1 into 2 square plus 3 into 2 plus 4 becomes 14. And again 14, 1 into 2 plus 4. So this is becomes 6. So 6 is found as remainder. Any question?
Sir, I have a question, sir. I raised my hand.
Yeah, go ahead, Katraju.
Sir, for example, in the same slide, find remainder for 27846 is divided by 8. But then how did you get this expression, sir? 2x to the power of 4 plus 7x to the power of 3, 8x square plus 4 plus 6. How did you, as a student, how should I know this as a expression? What is the methodology to get into this expression?
Yes, 27846. Basically, it is 2 into 10 to the power. If we analyze the positional value, basically it is position value system, no, we are using. So 27846 actually has a value 20,000. 2 into 10 to the power 4 plus 7 into 10 cube plus 8 into 10 square plus 4 into 10 plus 6, isn't it?
I mean, we are not mathematics students, sir. So there is some amount of.
Now you got the point or not?
Again, I'll listen to.
Instead of telling 10 to the power and so on, I see how many zeros are there? 20,000, how many zeros?
20,000 4 zeros.
Basically, this number is actually 27846 or mixed they are giving. Actually, it is 20,000.
Yes.
20,000 plus how much? 7,000, isn't it?
7,000.
That
Yes.
is the positional value system. 7,000 plus 800. 800
plus 40 plus 6.
Plus 40 plus 6. So
and one more small doubt, sir. Okay, now I get it. What is polynomial in the last slide? Polynomial and linear polynomial. What do they mean, sir?
No, see,
Previous
don't get into that. You understand this particular thing. Okay. This is more important. Understanding polynomial is a very difficult thing. Don't attempt that right now. Okay.
Polynomial, easy also. Polynomial is nothing but this kind of expression is called polynomial.
This expression itself is polynomial.
Is polynomial. If you binomial, and there is only two terms are there. It's called binomial.
Two variables.
Yes, two variable you can say. Yes. No, not two variable. 2 power. Power of 2.
Power of 2.
Binomial.
Poly means multiple, is it?
Multiple. Polynomial. So there will be here in binomial there will be maximum power. Maximum power will be 2. But in polynomial, maximum power should be higher than that. So it's called polynomial. So polynomial gradually increasing order, decreasing order will be there. Say this like this 2 into 10 to the power, there are 4 zeros. No. So 10 to the power 4 means what? 10 into 10 into 10 into 10, isn't it?
Yes.
So this we, instead of writing in always in the into, there is a power this called power. I write 10 to the power 4. 10 to the power 4 is basically this one. So it is 2 into 10 to the power 4. The 20,000 means 2 into this 10 to the power 4. Okay, 20,000. So that became 2 into x to the power 4. So x to the 4, something x to x cube, so on, it is called a polynomial. So basically, one number actually is translated into a polynomial. Okay. Any number can be translated into a polynomial. And a smaller number also can be translated into a polynomial. So by putting remainder theorem, we can, I can determine whether there is a remainder, how the remainder is coming. Okay. Now it is clear?
Okay. Yes. Thank you, sir.
Excuse me, sir.
Yes.
Sir, in this example, this particular number 27846 is divided by 8. In such case, we are getting x as 2. If the same number is divided by 14, will the x will be 4?
Yeah, surely. Suppose I try to divide it by 6. 6 will be 1 column 4. So then x minus 4 is 0 and x will be 4.
No, sir. If same number divided by 14.
X is minus 4, not plus
It will be minus 4. In case of 14, it will be minus 4.
That's
10,
what.
10 plus say 14. So
4
if x is equal to 10, it is actually, so it is x plus 4. Isn't it? X is 10. X is 10, so x, and x plus 4, 0 of that is x plus 4, 0. So x is equal to minus 4.
Okay.
So x always will be 10, sir, then.
X is 10.
Always 10.
This remainder theorem, we will put x is always 10. So 10
If
is
x
my
is
base.
always 10, then it is
10 is the base in the decimal system. So we are all using decimal system, but suppose I will just skip it.
So if it is by 6, sir,
it is a 16. Suppose again I did apply measurements for hex numbers. So hexadecimal, there everything you have to use 16, not as 10. There if I apply remainder theorem, my x will be 16, not 10. Okay.
Rameswara Garu, you have a question?
Sir, my doubt is one more, sir. If
Just
the
a minute.
same number is divided by 6, then it is minus 4 or plus 4?
Minus.
If
6 will
same
be
number
1.
divided by 6.
Same number if I divide by 6.
By 6.
6 is equal to 1 and vinculum 4.
1 vinculum 4. Okay.
Sir,
If it is 6, 1 vinculum 4. If it is 14, 1 plus 4.
14 is 14 after all.
14.
Now
Sir, 14 case minus 4 will not come, na? If it is 14.
If it is 14, minus 4. X is minus 4. If it is 14, x plus 4 is equal to 0. 0 of that expression, q, is x plus 4 is equal to 0, so x is equal to minus 4. Yeah. Now a challenge came. This is still 156.
Just a minute. Kaipa Rameswara Garu, you have a question?
Sir, suppose, for example, if it is to be divided by 4, how I have to write?
That actually this particular that vinculum is done only for less than
Above 5.
only above 5. It doesn't hold good. I have to do for everything.
Okay, sir. Then one more doubt, sir. This if this figure is 6-digit figure, then I have to write x to the power of 5 plus x to the power of 4 plus x cube plus x square plus x plus number. Is it correct?
All might say.
If it is a 6-digit number, for example, it is a 327846.
Yes. It will there will be x to the power 5. X to the power 5 will be there. Yes.
3x to the power of 5 plus 2x 4 to the power of 4 like that. Okay.
First think it as suppose you are telling that there will be more digits like 3 into this 0, 0, 0, 0, 0. That means 3 lakhs. 3 lakhs.
3 lakhs. Yes.
So 3
plus
lakhs.
20,000.
There will be 5 zeros. So 3 into x to the power 5 will be there, obviously.
So 5 to the power of 5.
3 into 10 to the power 5, so 3x to the power 5. Now see,
Okay.
so this we can practice. I think it is clear now. I'll go to the next slide. So application of remainder theorem, where remainder when the now divisor itself is 3 digits. So 27456 is my this thing earlier also. 27456 is there and divided by 156. Now the 156, okay, now the number is expressed as this one with x is equal to 10, and 156 also is expressed as let me square. X square plus 5x plus 6, which can be factorized to x plus 2 and x minus x plus 3. X plus 2 into x plus 3. Now, zeros of this expression, the divisor 156 will be x is equal to minus 2 as well as x is equal to minus 3. We may work with any one of them. So taking x is equal to minus 3 and replacing x by minus 3 into 7456. So 2 into minus 3 to the power 4, x into minus 3 cube plus x minus 3 square and 162 plus 36 minus 15 by is equal to 0. So this become remainder is 0, becoming in one go. But here actually taking x is equal to minus 2 in this case, replacing with x is equal to minus 2 with this one, we get 2 into minus 2 to the power 4, replacing now we all this, but the 10 into 10 to the power 4 and so on. By putting x is equal to 10, we get this original number, okay, in this expression. But when you put x is equal to minus 2 or minus 3, we'll get the remainder. So let us see when x is equal to minus 2. So replacing x by minus 2, so it is we are getting this one, and minus 12. Minus 12, again minus 12 became minus 1 and then into, because it is minus 1, minus 12 is minus x minus 1x, 1 into minus x minus 2. So in that in the x I put minus 2, so it becomes 0. 100. So it cannot be minus 2 is a minus 12 cannot be a remainder. So it actually comes to 0 as remainder. Now, any question on this? So basically, sometimes if it is factorizable, if it is not factorizable, then it creates problem. It cannot be remainder theorem guarantee cannot be applied. It will be all these Butowar square Venus pro AC, and you know that some people something like that. Have seen this one? Some people.
Yeah, Gautam ji, anything you're stuck?
No, not stuck. This anyone has the idea of this one? Minus b root over minus b plus minus root over b square minus 4ac divided by 2 I say. Anyone encounter this one in life?
It's a solution of quadratic equations.
Solution of quadratic equation. So this x square plus 5x plus 6 is a quadratic equation. This is factorized very clearly here. Had it not been factorized, it would have been such an expression. But I don't know how to apply remainder theorem when the roots are like this, some roots are imaginary and some roots are surds, I mean irrational. Okay, this I don't know. I have not studied that. I think it cannot be applied. In this case, the 156 is x square plus 5x plus 6. It easily factorized into x plus 2 and x plus 3. And so therefore we could have applied in case of 3-digit number. So that way it can be done also for 4-digit numbers, 4-digit divisors. So I go to the next one. Okay, no question from here. Now challenges comes in this one. This is actually, again, this is a failure, you can say, of remainder theorem.
Sir, one small doubt, sir.
Yeah.
If it is to be divided by 4-digit number, then how we have to proceed, sir?
4-digit number
example,
will be, they can be factorized. If there can be factorized, at least one of them will be in a small, like this, x plus 2 or x plus 3, with a x and a number, then it can be done. At least one of the factors, if there is small, at least one of the factor is small, like this, x plus 2, x plus 3, x plus 1, x minus 1, x minus 2, and anything, then it can be done. Otherwise, it will be difficult. If it is all becomes like this one, irrational or something like that, it will be difficult. Like here also, it is not irrational, it is simply a fraction. Challenges. Find remainder when 1, 2, 3, 4 is divided by 23. The number 1, 2, 3 we express as x cube, 2x square, 3x plus 4, where x is equal to 10. Similarly, 23 can be expressed as twice x plus 3, whose 0 is at x equal to minus 3 by 2, a fraction. According to remainder theorem, putting x minus 3 by 2 in place of x in 1, 2, 3, 4 becomes this one, very complicated. Minus 3 by 2 cube, minus 3 by 2 square, all minus 3 by 2. So minus 27 by 8, and then 9 by 2, minus 9 by 2, 4. It becomes 5 by 8. Result of this becomes 5 by 8. Found to be, how by 8 found to be the remainder. But it is an impossible thing. Actually, remainder, I calculated, actually remainder is 15. But how this actual remainder when 1, 2, 3, 4 is divided by 23 is actually 15. So 5 by 8 is found to be remainder according to remainder theory, according to remainder theory. However, the interpretation of fractional remainder is to be found out. It actually is now not to be found out. It is a failure of remainder theory in this particular arithmetic case. Remainder theory is basically originally for algebraic expressions. We applied it in case of when it is can be applied. Remainder theory is meant for actually polynomials like this, px and qx. And we applied it when it was easy. Can be applied if there is a digit starts with, or at least a factor would be starting with x, one digit. 23 has no factor. 23 has no 23 has no factors. Suppose had it been 24, had it been 24, we would have gotten it. Don't think that always that if it is starting with 2, you cannot do it. No. So 24, so twice x plus 4 is equal to 0. That means x is equal to how much? X is equal to only minus 2. So if it is starting with 2, but it is an even number, we can do it still. But we cannot do it odd number like this, where it becomes x, it becomes x is equal to minus 3 by 2, this kind of things. Okay. So So I come to the next one, next part. If any question comes, you can ask me
I think
again.
in the previous slide there is a mistake there.
Where?
Yeah, this second term 9/2 that you have here, that should have been 18/2. Because it is -3 square divided by 2 square, which is 9/4.
18/4. 18/4 is 9/2.
9/2, right. Okay, got it.
Okay. And okay.
Yeah, it's correct.
Now, Vedic Sutra, colon actually means differentiation. Actually, differentiation, this kind of calculus was actually discovered in India. And later on, know that ship full of, see, one very, very barbaric culture, they burnt our all documents, all research documents, because the rishis were basically research workers. And centuries old research these books. Actually, there is no, unfortunately, there is no photocopy or these kind of things. There are only handwritten things are there in Nalanda and in Jain and so on. When the barbaric culture came, they all burnt off all these things. And it is said that for 3 months, the books of Nalanda was burning. Similarly for Ujjain. But another culture who came, they're actually not uncivilized that much. They understood the potential of the Indian texts. So with ship full of big ships full of Indian documents all went to Europe. And from there, Newton, Leibniz, all these people learned this, discovered this, they rediscovered, you can say, interpreted and could make it actual. That is their credit. They published to the world.
Excuse me, sir.
We kept it in within ourselves, but they published, and so therefore the origin of differentiation, this is not Newton, but it is actually India. Please tell me. You contradict to my what I told. Actually, I maybe that's like
Yeah, Lakshmi garu.
Yes, sir. Yes. అది 9/18 వస్తుంది కదండి. ఇది
అదే
9/4 I think, no?
No.
The second term,
Yeah, just now
like 3 is
just
9
now
and 2
it
4
was
2 to
explained.
the
It is the previous slide.
yeah.
Not
Second
here.
term,
Next.
27 by
Yeah.
8 plus 9 by
9 by
it should be
4.
3 is 9, 9 to the 18 by 2 to 4. 2 4 is 8. So it will be 18 by 8. So it
18
should
by
be 9/4 I think. No? Just
18, 2 square,
2
isn't
square
it?
is 4 కదండి.
2 square is
Yeah,
4.
2 square is 4.
Ah.
2 4 is 8 కదా.
అది కాదండి, మీరు మళ్ళీ మ్యాథమెటిక్స్ కాస్త చూసుకోండి. ఆ పై 9కే 2 వర్తిస్తుంది, కింద దానికి కాదు.
9/4 into 2
sorry.
is
Okay.
9/4. Yeah, it's clear.
9/4 into 2 is 9/2.
Yeah, okay.
Yeah, Goutamji, it's clear.
Thank you. Achha. So I come
Okay,
to this
thank you.
So it is the differentiation came here, and sequential motion. Differentiation deals with differentiation. There is a relation. See again, ignore this part. This is actually so many times I have to put this square and so on. You copy it and paste it here. There is relationship between differentiation and factorization. Now, example 1. So first I'm putting the background. Actually, maybe that because of the paucity of time, I cannot come to exact. I didn't translate it into slide, but I discuss from the book. So first you know the background. How it happens actually at different level of differentiation. How many people, I don't know how many people know about differentiation, integration, at least differentiation. So these are purely algebraic. At present, there is no arithmetic things here. So example 1 is x square plus 3x plus 2. It is purposefully he kept as a small things like x plus 1, x plus 2, x plus 3, x plus 4, etc. So first we start with this one, x plus 1 and x plus 2. Take x square plus 3x plus 2, which is factorized as x plus 1 into x plus 2. So suppose we say that this is A, first term is A, and this is second term is B. Now when you differentiate it, it becomes twice x, because you can memorize. Those of you who do not understand what is differentiation, is equal to on a differentiation of, it's called ddx. This ddx of x to the power n is n into, how many people understand this differentiation? This must be there. There are Patarji and so on. There will be mathematical background people also, no?
Yeah,
So this is the general formula, n into x to the power n minus 1. This is the difference. This is called differentiation of a expression, of a power expression. Otherwise, you see e to the power x, ddx of e to the power x is e to the power x, ddx of sin x is equal to cos x, ddx of cos x is minus sin x, and so on. So many other things are there. All have actually, all this e to the power x, sin x, cos x also can be translated into a polynomial. There will be large polynomial series, infinite series for polynomials. So these are, forget about all these issues. Presently, we are dealing with only power of x. So if power of x is n and we differentiate it, so n comes in the left and power of x is reduced by 1. So it becomes n minus 1. So you'll always find that. So this came to left. When you differentiate it twice, x square, it becomes twice x. 2 came here in the left and x to the power 1. And then become 3x. So x to the power 0, it becomes over the 0 is 1. So 3. So twice x into 3. So this is actually, you find that it is very interesting. It is addition of these two terms, A and B. So it is A plus B. So background is being, I'll in this course, I will first, in these slides, I'll produce the background. Again, take the higher example. X cube plus 6x square plus 11x plus 6, which actually is, when factorized, here we are factorizing that because we know that it started with that. But suppose unknown things are there, then also we can, by producing different levels of differentiations, and any lower, any higher differentiation or becomes actually lower polynomial becomes and can be differentiated and can be factorized, then that factorization keeps also int for the actual one. That is the idea of the differentiation mixed with, actually factorization, it should be factorization by differentiation. Both are together. So let us start with this. X cube plus 6x square plus 11x plus 6, which actually is factorized, can be factorized as x plus 1, x plus 2, x plus 3. So these are A, this is A, this is B, this is B, and this is C. So D1, it is 3x square, see 3x square, this differentiates to this. This becomes 2 into 6 is 12, and power became x only, x to the power 1. And 11 differentiated came to this one, 11. So this is actually A and B grouped together. So sum of AB, AB means actually AB plus here, sum of AB, this particular small one. Actually, in the book also, sigma is also here. Sigma is sum of sigma. AB actually means, actually is called AB plus BC plus CA. AB plus BC plus CA. Thing is become complicated, isn't it? It is like this. The first one, see, this is the first one. X square plus the same as this one. Okay. Because it is x plus 1 into x plus 2. This one is x plus 2 into x plus 3. Hey, yeah. And this is x plus 3 into x plus 1. Okay. This one. So this is the sum total of this one. So it is the sum of AB. Now D2, again we differentiate it. So 2 into 3 becomes 6. So this becomes after differentiation, 12, this becomes 12. So it becomes constant, and it is accuracy twice of x plus 1, or twice 2 into a plus b plus, the a, b, c. So it becomes 2 factorial of sum of the factors. Differentiation of different orders can thus be solved for factors and indicate factorization. This kind of things will indicate factorization. I will take higher examples. Where example 3 is actually, again, these big expressions, actually it is x plus 1, x plus 2, x plus 3, x plus 4, ABCD. This is ABCD. D1 actually is 4x cube. This big are not, I am not given. 4x cube plus 30x square. See, I differentiate it. It becomes 4x cube, isn't it? And 3 into 10 is 30. It becomes 30x square. 35 into 2 is 70. So it will be 70x. And this 50 came here. X. Okay. Now this came. So this one is there. I find that the sum of ABC, these three terms, so first 3 terms, and again you do these, and this one. Then comes this, and this one. Then comes what remains? I think all these 4 terms come, and sum of ABC. ABD. ABC, ABD, ACD, and BCD. The 4 terms will be there. So this is, if we do it, multiply and add, it will come to the same thing. Then D2, this 3 into 4 becomes 12. So 12x square. 2 into 30 is 60. So 60x, and this 70. So it is actually 2 at a time. 2 at a time. If we here I actually, because that much manageable, these 6 terms are there. AB, AC, AD, and so on. This basically is called combination. Combination of this A, B, C are combined into there is a permutation and combination. It's called combination. Select 2 at a time. Don't order is not immaterial. Order is immaterial. Permutation order is there, but combination there is no order. So AB, AC. So this is AB, then AC, then AD. Oh, that is only CD. So AB, AC, AD. How much will be there? AB, AC, AD. Then BC, BD, 2 at a time, CD. These 6 terms are this one, and then finally it becomes twice this one. So this actually is twice this one, 2 factorial. 2 factorial same as this. And these 3 we find 24x plus 16, 6 into addition of all this ABC. So because basically 6 is actually 3 factorial. Basically factorial is nothing but like this. 2 factorial. Put it like this. There is 2 ways. Sometimes we put like this also. It's also factorial. 2 factorial is 1 into 3 factorial means 1 into 2 into 3. It becomes the number of permutation. See, there are two things. Suppose there is 2 numbers called 2 and 3. With 2 and 3, you can produce only 23 and 32. Because there is only 2 possibilities. But we say that we suppose we write 4, 5, and 6. With 4, 5, 6, you can produce how many 6? There will be 465, there will be 564. Total 6 numbers will be there. 564. This is called permutation. The arrangement will be 1 into 2 into 3. So this is factorial 3, it is actually 6. 1 into 2 into 3 is 6. So there will be, for 3 objects, there will be 6 combinations. Similarly, for 4 objects, if we just want to all the permutation, all the arrangements, all the different unique arrangements, there will be 24 because 4 factorial is how much? 4 factorial
1 into 2 into 3 into 4.
Is equal to that way 1 into 2 into 3 into 24. These are all called permutation combination. Combination is used here when 2 at a time, 3 at a time. So here 6 came because of some reason, because the 3C is called 3C2. Sorry, 4C3. 4C3 is 4C3 is the 6. So therefore 6 term came. So now, so this is basically the differentiation of level 3. Third differentiation, it came to 3 factorial and sum of all factors. I come to higher one. After the differentiation, the factors can be identified and the original polynomial can easily be identified. This again I repeated. Now example 4 I am taking x to the power 5 plus 5, 15x to the power 4, 15x to the power 4 plus 85x cube plus 2 very big, looking very big, but actually it is x1, x2, x plus 1, x plus 2, x plus 3, x plus 4, x plus 4, say we should do this factor of that. Now d1 of that, say 5 into x to the power 4. Now you know x to the power n is n into x to the n minus 1. Here 4 into multiplied by 15 becomes 60 and this reduces to 1. This becomes 60x. 85 into 3 is 255. 225 into 2 is 450 and 274 came without x. This becomes the sum of ABCD, 4 at a time. There will be so many terms, 5 terms, 5C4. 5C4 is actually 5 into 4 minus 5 into 4 divided by 1 into 2, isn't it? Am I correct? We know permutation combination. So there will be 10 terms. In this case, there will be this combination ABCD combination will have 10 terms. And so 10 terms adding will be this one, D1, what is called D1. Now again, this is differentiated further. 4 into 5 becomes 20x cube. 60 into x cube differentiated to 3 into 60 is 180. This becomes 510, 2 into 255, and this 450 remains here. So this becomes actually factorial 2, means 2 times of sum of ABC. ABC actually is 5 into 4 into 3. How many? Let's see how many terms should be there. 5 into 4 into 3 divided by 1 into 2 into 3. Again, 10 times 10. 10. Again, there will be sum of this is also 10 and this is also 10. So there will be these 10 terms. Maybe I will write sometimes that 10 terms, 10, how many terms? There will be 10 terms of this one, and you'll find that two into this, all these things. Again, it's further into differentiation. So 20 into 3 becomes 60, 60x square. 180 into 2 becomes 360 and 512. 6 times all these sums together. Means actually there will be 5 into 4 again will be 10 terms. 5 into 4 into 1. And then
Sir, a
finally,
small.
Yeah,
Sir,
please let him complete, and because we are heading towards 8 o'clock.
so
Anything
it
after
actually,
8 o'clock.
finally, further we differentiate and becomes 120. You can see it is transparent, very transparent, because it becomes smaller and manageable. It is 5x plus 15, no? So x plus 1, x plus 2, x plus 3, x plus 4, and x plus 5. If we multiply, it will be 5x square, 5x. And then 5 plus 4 plus 3 plus 2 plus 1 is equal to 15. And then this particular expression is 24 times. This is 24. 4 factorial is equal to 1 into 2 into 3 into 4, so it's 24. So this is ABCD, and then this is constant. Now, if suppose the big expression, that idea is like this. I don't know, the time is not there because this learning the differentiation itself actually takes time for those who didn't know earlier. And so here the examples are given that it is up to 5 levels it is differentiated. And yes, at any level, if we find it manageable and can be factorized, that gives a hint towards the actual expression. That gives the, suppose this one could be factorized here. 5x plus 15. So it is what? X plus 3 is a factor of that. X plus 3. So x plus 3 can be one of the factors of, it's possible that it is possible that either it is a factor in this case, because it is very easy to find that it is, take 5 common and it becomes x. Like 5 common and x plus 3 becomes 0. This is a small number, manageable expression. And x plus 3, we can then go back and found that any of the differentiation, d2, d1, and so on, and the original expression can be a factor of that. What can be done this way? Now I put x is equal to minus 3. I put x is equal to minus 3. Remember the theorem? So time doesn't permit here. So in case of x, I put minus 3 and find whether it is 0. If it is 0, that means that there is a factor of this, either d3, this x plus 3 I got from d4. But I keep on putting minus 3 in place of x in previous ones, d3, d2, d1, and the original expression called E. So the original expression is called expression E. This is E actually. This is called E. The original expression which I want to factorize using differentiation. So I put, then it is, suppose it is failure. But one of them I found it is there. So I divide it, get another factor. Suppose the D2 produces another factor. So suppose
Yeah, Goutham ji, it's 8 o'clock. Sorry, I'll have to go for
sorry.
Pradhana.
No, just 1 minute. Suppose x is equal to minus 3, it doesn't put 0 in original expression, but it produces in one of them. There, if you divide it and put another expression like that, another factor, that factor I can then use elsewhere. That is the idea. And this is coming from, I didn't write it, just 1 second. There is a good Corona time or something like that. There is a good dance that is. Sunnam Samchitra, that's anyway, I will tell you. Now you can go for searching.
Okay, can we go for Pradhana now, Goutham ji?
Okay, please.
Yeah. Baugar.
Okay, thank you so much. We will continue this.
Is there anything else I can help you with today?
1 minute.
Baugar.
1 minute.
Yeah.
Thank you, Goutham ji.
Namaskar. Thank you. Welcome.
In fact, you have covered more than what is expected, in fact. Gone into differentiation and also factorization and giving a relation between them. Let us see how many people have enjoyed it. Those who have enjoyed it, definitely they will take it forward. Now let's go for Prarthana. Venkat Narayan garu.
स्वस्ति प्रजाभ्य परिपालयन्तान् न्यायेन मार्गेण महीमहीषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथिवी सस्यशालिनी देशोऽयं क्षोभरहितो ब्राह्मणाः सन्तु निर्भयाः अपुत्रा पुत्रिणः सन्तु पौत्रिणः अदनाः सदनाः सन्तु जीवन्तु शरदां शतं सत्यं वद धर्मं चर स्वाध्यायान्मा प्रमदः सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ शान्ति शान्ति शान्तिः ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्ति शान्ति शान्तिः सर्वे जनाः सुखिनो भवन्तु स्वस्ति
ధన్యవాదములండి వెంకట నారాయణ గారు. Thank you so much. Now let us request Talla Chittibabu garu to go for Janagana Mana, please.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद
Jai. ధన్యవాదములండి చాలా చిట్టిబాబు గారు. Now let us go for continuation of this session.
But only a few people are there, you know. So, but still
26 people are there. Now, just to give the name, it is
Right.
called this principle. The principle of putting the differentiation to anywhere is called Addam Addeno. Addam Addeno. It is called Addam Addeno. So basically, the idea is that I go back to that one. Addam Addeno. I'll write somewhere. As I was telling that one of them I got the factor. I find that whether any of the earlier differentiation has this factor or not. If it is original expression itself satisfied with x equal to minus 3 becomes 0, so it becomes a factor, and directly we divided it. By dividing we get the other term. or you can suppose x minus 3. So x minus 3 is a factor. See, here x minus 3 is a factor, I know. It's the original one. X plus 3. X plus 3 is a factor, I know. So when I divide it by x, suppose the whole thing I didn't know. Fortunately, I designed it to demonstrate it is another one. So x plus 3 actually is a factor of this one. Now, when I divide it into x plus by x plus 3, the remaining will be x plus 1, x plus 2, x plus 4, x plus 5. It will be also a very big expression. So I do not understand it. So had it not been there, any other thing. So there also I do the same procedure and can find gradually other factors also. Or suppose it is directly not divisible here. It's not. It is not a factor. Sometimes it happens that it came from D4, but it is not actually factor of E, the original expression. So in any of say D1, D2, and so on can be a factor. See, other factor can be there after division. I get other factor that I can put in the original expression. That way, you go back and forth, and it's called Addam Addena. Addam Addena. Addam. I'll include it in this slide. Addam Addena. ADYAM and ADYENA. ADYAM and ADYENA. Sutra. This is Addam Addena Sutra. Name of the sutra is Addam Addena. So in the Addam Addena Sutra, anyone has question on this?
Ketaraj garu, you have raised your hand.
Yes, sir. So thank you, sir. In this slide, differentiation, factorization, slide number 3.
Yeah.
Only the top line after the differentiation factors can be identified. That is available in the notes circulated, sir. The rest of the working is not there, so it's blank.
Oh, this actually I modified it yesterday. Yes, that's a good idea. I'll again the latest version of this. I'll share. Okay.
Okay. Thank you, sir.
Okay. Thank you. There are no more questions.
Now, just quickly go through this one because some people may be interested in this computer background is also there. The hexadecimal numbers. These basic mathematics can be equally applicable to hexadecimal numbers, where the number digits are used as 0, 1, 2, 3, 4, 5, 6, all the decimal digits up to 9, and then A, B, C, D, E, F. Whose values are 10, 11, 12, 13, 14, and 15. So you see, quickly go through this one. So there'll be positional system again. So this is actually consider the addition of this and this. And there you find the vinculums in here. Up to some vinculums are there and then can be same way I now here I put that near a hexadecimal base. So this particular when AP is actually equivalent to 9 in hexadecimal. AP actually corresponds when AP is actually 15. So since it is 16 digits, so 15 is close to the base. 15 is very close to base. So the equivalent to becoming 9, close to 10. So that actually. So FFF, these things, it becomes 13, 14, and so on. So if I do it like that, it actually it works. So that we have seen that how this is part the AB part, and then this is the n minus a minus b. You understood? The n minus a, n minus b, and so on. It becomes my result. These are the two numbers have to multiply.
Yeah, Padmavati garu, you have a doubt?
అవునండి గురుగారు.
You can raise your hand and ask.
రేట్ చేశానండి సరిగ్గా
Right.
రాలేదనుకుంటా.
చెప్పండి. Yeah, go ahead.
ఒక వరుడు
These are
చెప్పారండి ఇప్పుడు.
I've shown
అర్థం
for it.
అర్థం
The same
మొత్తం
thing can
ఏదో
be done.
అన్నారండి.
Now here also there is interesting thing of Pythagoras theorem. Then I come to geometry. Let me just cover one. This hexadecimal may not be very suitable for others who do not understand them. But Pythagoras theorem is actually from school level itself we learned so many different methods. Sometimes some proofs are very complicated and so on. Here you find that very easy proof is there for Pythagoras theorem. For that, I have to show that a square plus b square is equal to c square. C square. How to prove that? First I do it a plus b. I put a square. A plus b, a plus b. So a square I write. I draw, but all the sides are a plus b. And with a and b, this partition. Join these things. Join this. And join this. And then we call that C. Now, by this geometry and this calculation, I have to find that a square plus b square equals c square. See, draw, I have written here the procedure. Draw squares ABCD with sides a plus b. Mark points PQRS on the sides of this one, PQRS, and these are the partition of A and. So always the left, this same sequence, BA, 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 or A, B, A, B, A, B, inside this one. It can be proved that PQR is a square because see this one, you see that this is similar triangle and similar triangle. This one actually is so that one. This angle is same as this angle. This is 90 degree. So therefore, this also is 90. So therefore, it can be proved as a this is also a square. Okay, and we put it as C. Now, area of ABCD. Area of the whole thing is a plus b whole square. This is a square plus 2ab plus b square. And total area of 4 triangles. Each of the triangular formula is that base into height. So A half AB. Each of these triangles, this is half AB, this is half AB. This small triangle. This is also half AB, base into height. There are 4 numbers of such AB, half ABs. So this comes to twice AB. There are 4. 1, 2, 3, and 4. Oh, this is half AB or this is half AB. This is also half AB. And this is also half AB. So there are 4 such triangles. So totally it becomes 2 ACB. And therefore, and this is inside is C square. Inside is C square. Inside square is C square. So therefore, the whole thing is A plus B whole square. So this is equal to C square plus 4 into half AB is equal to twice AB. This twice AB cancels. And we are left with A square plus B square. So do you get it? Is it easy? Is it a very easy solution? Very easy. You can visualize.
Yeah.
You can directly visualize that is happening in front of your eyes. Am I correct?
Yeah.
Any questions? Thank you. My slides end here, but if you have any questions, or you can.
Yeah, Padmavati Garu, you are asking a question. You can now ask again.
Ardhamadena, that means, please repeat, Guru Garu. I can't understand what is the meaning of Ardhamadena.
Actually, Ardhamadhyana, it is the Ardhamadhyana Sutra. It is named here in this procedure in the book. Well, I also do not the Sanskrit Ardham, Mane Adi, Adhyana. So
Adhyam, Adhyana, okay. Now I
Adhyam,
can understand, Guru Garu.
Ardham is actually Adi. and
Although
Adhyana.
Sanskrit, it's a Sanskrit sentence,
Yeah,
so
the name of the
Madam
Vedic
can
Sutra
easily
is-
understand. She can tell us.
So you have to understand Sanskrit. I'm not very strong in Sanskrit, but it is coming from Adi. Adi means beginning. So Adham Adhyana. Something is in beginning.
Adhyam Adhyena.
Adhyana means
Adhyam.
Adhyam Adhyena.
Adhyam Adhyana means actually maybe which is coming in the beginning. Can start the beginning of something like that. I don't understand how they actually applying here, but the procedure is as I told. You understood the procedure, na?
Right from the beginning.
If the whole expression is not visible, not the factors in the original expression E is not visible, very prominent, then you keep on differentiating, or you differentiation let me complete, and then you start from the lower ones and find that in lower one I find that there is a factor called x plus 3, and there x is equal to minus 3, I put in the original expression and find that is 0. That means x plus 3 is a factor, actually a factor. So I divided original expression by x plus 3, and then it produces the other factor. I try to factorize, or again I proceed with that remaining expression. I again do D1, D2, D4. There will be no D5. D4 will be constant because it is one lower. So maybe in D3, I get another factor, maybe. That so much broad broad trial I didn't do, but I can do it. Then I can. Otherwise, see, suppose it is not a factor, x plus 3. At least in D1, D2, D3, the other ones, I got this x plus 3 from D4. I can try with D1, D2, D3, whether this is factor or not. In any case, it is factor. Say I can factorize it and put another factor. That particular factor I can try with E expression, original expression, because my original aim is to factorize E. So therefore, in any of them, if I do, it can be factorized. That way, it is factorized. So examples are there. Because the paucity of time, if we are interested, I can discuss one of the examples. Should I do it?
Yeah, I think now we are running out of time again.
Yes,
It's
yes.
28
So
minutes.
better, maybe that if one class can be allocated in the letter, but
But then if there are questions in between, and that will eat away a lot of your time. So the questions, if we take up at the end, your flow of whatever you are teaching may be there.
No,
But at the same time, doubts are also to be cleared. Both are recorded.
Now that actually, because this mathematical, there is something actually.
I know.
But doubt is.
But if the question becomes too lengthier, the doubt clearance becomes too lengthier, then the time is lost.
But if the doubt remains, what happens actually? Afterwards, they may forget also what was the doubt.
Right. Yeah, I think
it remains all the time.
Babu
You can
Garu,
stop the recording.
Babu Garu, what I think is what Goutham is doing or saying is right.
Right.
Mathematics, unless we clear that out, they will not proceed further.
they'll be switched off.
They will
People
be
will be
switched
switched
off,
off and
yes.
will not learn anything further. All the time will be wasted for them.
Yeah. Okay, now I stop the recording.
Yeah,
Okay.
yeah, stop the record.
Awesome.